So today we're going to talk a little bit about Folio Photonics, and the obvious place to start, I guess it's a name that's not familiar to everyone. So when formed, why formed, what's the idea?
Thanks, Phil. So my name is Steve Santamaria. I'm the CEO of Folio Photonics. Folio Photonics was founded in 2015. It was built in the lab of a professor here in Cleveland, Ohio, at Case Western Reserve University by the name of Ken Singer. He had a National Science Foundation grant and exploring using photonic materials and chemistry and embedding them into layered polymer films, and that for him to use for storing of data. And so our product is a film-based storage product that looks similar to Blu-ray or the archival disc, but it's completely different manufacturing technique and different chemistry. So we've been around now for about 6 or 7 years as we've navigated getting the product built, getting it tested, getting it working. And most recently, the announcement we gave is that we are writing and reading to an 8-layer film-based folio disc, so 8 per side, so 16 total, which gives us a massive increased capacity over traditional optical storage.
Okay, yeah, so you have recently come out of stealth mode, as I think they call it, with the active archive storage. And it would be good, I guess, to understand, I think you've described it as a new era of data storage. So that's quite a big claim, obviously, but what's different? You've obviously given us a bit of a hint there, but what's different?
Yeah, so when you look at data storage, and traditionally, what you're starting to see, and there are a lot of great products out there that are used in the data center. You have flash, you have HDD, and you have tape. And as people, what's happening in the industry right now is people are saving more and more data. They're archiving data. So you're trying to build up these great big data warehouses or these data lakes. People don't want to delete it because there's this whole new rise of artificial intelligence and machine learning tools that go and start analyzing the data. So instead of the old days where you would delete it and don't worry about it, now you kind of save it. You save it for 20, 30, 40 years, and you run fancy algorithms that scan through that data to find new business opportunities. And so what's needed is a way to store that data that is very low cost, very affordable, that doesn't use up a lot of power or big footprint, that is secure. And this is kind of where we are. We see, the world is moving into a new era where you're going to have your fast data, your primary data, but a secondary data is emerging. It's really data preservation and for long term, saving for 100 years and more. And so that's where we call the new era. And when we look at our product, it is aimed purely at that archival storage piece of that pyramid. If you think of the storage pyramid, this is kind of where we see our product fits best.
Okay, and in terms of sort of what you're aiming to do, I think one of the ideas is to address some of the IT sort of pain points, and the first one of those perhaps is the cost. That is an age-old thing, but cost versus capacity versus performance. So can you sort of characterize your technology, how it addresses that sort of eternal issue, if you like?
Sure. Everybody's looking for lower and lower costs. Every hyperscaler, every on-premise data center, as the amount of storage keeps going up and you're paying dollars per terabyte, it's, you're trying to minimize that cost. The current products that are used mainly for archive are the hard disk drive and then magnetic tape, LTO tape. Those have they're kind of different. And HDD is fast access, more expensive, whereas LTO is slower access and least expensive. And what we're trying to do is kind of combine the both. We'd like to give first access, meaning fast access, so you can find your data quickly, but at the lower cost profile. And this is what we think the industry needs, right? We coined the term. We say it's looking for active, meaning affordable, cyber secure, time to first bit, immutable, viable, and eco-friendly as our acronym. We think those are aspirational for the industry. You want to store your data long term on the least costly media possible, and you want it to last a very long time. A folio product, we estimate will last 100 years. Versus a HDD, which you have to replace every 4 to 5 years, and tape every 10 years. So if you're storing your patient data, you're a hospital for 100 years, it's not cost effective to move that data every 5 to 10 years. Put it on one piece of media, store it for 100 years. That covers the life of the patient. So that's kind of where we're at on this. The breakthrough for Folio is the manufacturing process and the material science that enables that. It allows us to enter at a price point lower than tape, much lower than HDD, and we think that addresses the number one need. So when we talk to customers, whether a hyperscaler or an on-prem data center, the first thing they always ask, "What's your dollar per terabyte? How much is it going to cost me?" Everybody wants to know. That's the first thing they ask. You talk to the big hyperscalers. What's your roadmap? How do you get to $1 per terabyte? Everyone wants to know, how do you get to $1 per terabyte? And so we have these conversations. We painstakingly go through. Here's our roadmap. Here's our pricing model. Here's our cost profiles. Here's how we will get there. And that's what gets a lot of the big guys really excited about what we're doing, because we have clarity on that vision.
Okay, and you referenced cybersecurity there, and that's another massive industry pain point. Clearly, the IT security industries are so entity in itself with all manner of things going on there, but storage has a role to play in that. So you mentioned immutability, which I guess is part of it, but can you just sort of highlight why you're addressing particularly ransomwares and issues and stuff? What's cyber secure about it?
Yeah, I mean, you called it out. I mean, the rise in ransomware and the cyber attacks are cost industries billions of dollars today. The average attack costs each company $4.5 million, or is what I just saw in a recent report. And so we're just part of a solution that's going to layer that cyber resiliency. But we have a couple features that are very unique. So first of all, a Folio solution is worm. So write once, read many times. So it's immutable out of the gate. It's not software worm. It's you're writing onto the disk. You are making your spots, and you cannot undo that. So data once written cannot be changed. It can be deleted, but it can't be changed. So that's kind of a good thing. So it's going to protect that data and avoid those modifications. Second, we use, along with tape, in the air gap. So all the media is not online all the time. And so with an air gap, that is just another effective barrier. A cyber criminal can't access data if they can't corrupt it if they have no access to it. So we believe that these two features will be pillars going forward about how to protect your archive data and preserve it for tens, if not hundreds of years.
Okay, and maybe the third, I mean, increasingly important for a lot of organizations is the whole, I guess ESG is the sort of the three letters, but the main part of that is perhaps sustainability, although I know governance is important around data. And what does your technology do about that? I mean, I guess there's sustainability being, I say perhaps.
Yeah, it's really exciting, and this has really become more and more. It moves up in terms of customers' desires in the last 2 to 3 years. When you look at data centers and you realize that in 2025, 3% of all electricity generated will go to power data centers in the world. And by 2030, that number, some people project, will be 10%, which is a massive amounts of data. So then you look inside of a data center, you realize that storage takes about 30% of that power. So in 2025, 1% of the world's power goes to storing data in a data center. And so anything we can do to help minimize that will help, a couple of things. It helps, everyone's trying to make their get net zero, right? They're making all kinds of promises and commitments for that. And Folio's technology is unique because data at rest requires no power. So if you're stored, you can, it's stored in the library system, but there's no power running through it. The disks aren't spinning. So only when you access it or write or read it is when you power up and you have to access that data. And second, and this is becoming a bigger concern, is that it doesn't require any special environmental temperatures or humidities. Folio's technology, optical, works in hot, works in cold, works in high humidity, and that gives it, open air data center, so lower that cooling bill. And so we believe that we can contribute greatly into the ability to create a more sustainable future and use less power.
Okay, and in terms of the actual sort of makeup of the technology, you referenced earlier, I think the multi-film thing. Are you able just to explain a bit more about how it works? And also you're saying obviously you're saying that it's lasting for up to 100 years. What are the characteristics that give you that confidence that it's going to be around that long.
So this could be a little bit of a history lesson. So you think of CDs and DVDs and Blu-rays, these are optical medias that have been around for 40 or 50 years. When they manufacture a disc, so we take a standard disc like this one, the manufacturing process is it's spin coating or sputtering that it additively, they lay the material onto the substrate, okay? And they got to the point where they could do 3 layers with high confidence that, you know, it's very manufacturable, it's very commercially feasible, et cetera. But adding the 4th layer, all of a sudden yields of manufacturing go down because you're starting to stack more and more material. It's not consistent, it's not used. And this has plagued the optical industry for decades. What Folio does, and I don't know if this is on video, but you can see it, is we make a film. So this film in my hand right now is 16 layers. And so in those 16 layers, it's 16 active layers that are extruded as a polymer film. And, you know, they go active buffer, and then all we do is laser cut and affix it then to the disc substrate. And that's how we get into our high capacity. Now, we tested this process up to 32 layers. In the lab, we've gotten to 80 layers. And it's the material science that goes into how do you embed the active writable material into polymer. You essentially have to then melt it and extrude it as a film to get, and then layer it, you know, get the layers very, very consistent, very close together and very thin. That's kind of our secret sauce, right? This is what we do. And this takes us years working on that. We have quite a bit of IP and trade secret around it, but it's going from traditional sputtering manufacturing, I mean, spraying layers of material on a disc and moving it into where you make all the layers at once as a film and do cut and one lamination. And that's how we can drive our roadmap into very high capacity. Plus, this manufacturing process is very inexpensive, right? Making films, and if you're familiar with the region in the United States where we are, this Northeast Ohio, it's very big on various polymers and polymer science. That's why we were founded in here. So it's a film based, gives us great economics, but it gives us a roadmap to great capacity. Now, you asked also the question, going, you know, you're talking about long life, you know, making the 100-year. You know, this is just very historical. You look at Blu-ray discs, you look at archival discs at Sony. They have very long life. This has been tested and proven. Obviously, we've not done a 100-year disc, but we put our disc through various testing that simulate advanced aging to get it there. And we're going to be very comfortable making that 100-year claim. You know, a little anecdote: when I took the job, when they were recruiting me, and they're telling me, you know, we're going to have 100-year life data storage. So one of the first things I did is I went up into our kids' playroom and I found an old Blu-ray. Now my kids, it's been 10, 15 years since this Blu-ray disc, and I think it was like, you know, Cinderella or something like that. And I just took it, found the Blu-ray player, popped it in. Now that has sat in my living room. It's been used to trace circles on paper. It's been sitting, you know, no fancy air conditioning, anything. It was thrown around as a Frisbee, popped it in, immediately played. So it started giving me comfort. This is a very durable product, because historically they're very durable products.
Yeah, and you've referenced the roadmap a couple of times. So again, I know you don't want to give away too many secrets, but sort of where are we now, and what do you think? I mean, you're talking about laying, I think you said up to 80. So I mean, what would you be confident expecting over the next sort of, you know, couple of years in terms of capacities?
Yeah, the hard part, you know, the first one, get the first product out. And, you know, and I showed you a 16-layer film. We're also making an 8-layer film. So the first product will be a 16-layer product, 8-layer per side of a disc. And, you know, we're targeting 1 terabyte capacity for that product. Still working on the pricing, but it'll be between $3 and $5 a terabyte is what we'll charge for that product. Then we want to quickly get into the cadence of every 2 years, doubling that capacity. So the next generation will be a 2 terabyte, then 4. You know, we roadmap up to 10 to 12 terabytes in the next, you know, 8 to 10 years, with a lot of comfort level that we can hit that. Then there's some real exciting products that we add in the future that are material science based, because the whole goal for us to allow a laser to read through all these different layers, every layer absorbs a little bit of the power from the laser, is to make them thinner. And so we're working with advanced materials and different dyes to put into those active layers, and real excited about things like quantum dots, which you can actually tune the actual material to a specific wavelength of the laser. So now let's say you have a multi-layer disk, but you have red, blue, and green quantum dots mixed in on a single layer, you can have a different optics or different lasers. You can have a red, blue, and a green laser. Red will only read blue, blue will be blue, green will read green. So triple capacity per layer. So that gets us very excited when we look at that. So we believe we have a real robust roadmap. And like I said earlier, the manufacturing process itself, once it's established with the first product, it's reusable in successive generations. So you don't have to build a whole new factory every time you increase your capacity. We're just adding layers. We'll modify the extrusions, the die head, right? The ports that make the films, but the rest of the process, it's all the same, right? So we're kind of excited about that roadmap.
And are you at the stage, have you been showing it to customers, doing any alpha or beta testing? So have you got some customer feedback as to what they're thinking, what you're doing?
Yes, we are showing it under heavy NDA to a small set of storage companies right now. They come into our lab now. Our setup, the drive that we have right now, it's big. It's on a table. It has to go through the shrinking process, which it's well known to get it down to something that's commercially ready. We've had third parties test and prove out the film. When we publish, we say, look, we're writing and reading the eight layers. They're able to duplicate that on their own setup. So yeah, we're starting to go out and show it. We hope to have an alpha in the next 12 to 15 months that will, a small volume alpha that we'll start to share with other people, and we'll start, getting more and more of the storage type of testing done. And, then hope our goal is by the, late 2024 is start delivering product commercially into the market.
Okay, and maybe just before we finish up, a slightly more general question. You mentioned earlier, obviously, part of the reasons for what you're doing is the fact that this data explosion shows no sign of slowdown. I mean, do you think the industry at all, clearly it's your product sustainable, environmentally friendly, but do you think the industry has any duty to sort of engage in the whole data creation, usage? You mentioned once upon a time people used to hit the delete button, they don't anymore. Or do you think it's okay for you to be there to look after whatever customers want, or should you be engaging in that debate as to life cycle management?
Yeah, look, I believe the industry has a responsibility to the people of this planet to do two things. Data, let's not kid ourselves, data is the fastest growing industry in the world, creation of data, right? I mean, I saw a report there where oil and gas industry used to be the largest industry. Now it's data. It's the Googles, the Facebooks of the world, et cetera. More and more people are doing with data, and data is the raw material for future innovation. It's about, it's all about data today. And we have to come up with a way to preserve that data and share that, because you want to avoid the conversation where you have to decide to delete something because you just don't know, right? So if you have medical records, you're going, wow, I'm gonna reserve a terabyte per my patient. Well, what if what you delete 10 years from now is the piece of information you need, right? Or the tools come out, that allow you to analyze, a bigger set of data. It's interesting. One of the fastest growing jobs in the world right now is a data scientist. There was even that job 10 years ago, but now there's data scientists to go out and analyze companies' data and find these trend lines and these opportunities. And the joke we always say is that I've never met a data scientist that wants less data. They want more data, right? Because you have these big fast computers, run all that data through and see what pops out. And that's what they want to do. They want to compare an image today from an image 20 years ago to 30 years ago, if you have it. Or every single year, the farmers are doing it right now. They're using satellite imagery, and they can tell, they can predict, rainfall patterns and things like that. And this was not available to do before. And it's responsibility of the industry, I believe, is to continue to innovate and create the ability to save and store that data, and also to share it globally. It has to make it less expensive. It doesn't do any good if Google or Amazon host everybody's data, and they're the only two that get benefit of it, and you got to pay. So we believe it's democratization of data, that data should be stored everywhere. Everybody should have access to it, and innovation should happen from the UK to South America to Asia, et cetera, to have access to these big pools of data. And you need a way to store it, and you have to do it affordably, because it's not cheap to store this data, right?
Okay, yeah. I mean, maybe just as we wrap up, for folks that are interested in, you say obviously there's a product's going to be out there. Are you looking still for people to engage in terms of testing and stuff, or are you happy now you've got your partners and now it's just developing and then come, I think you said 2024, bang, the product's there, or how can people get involved now?
Yeah, it's interesting that since we did the press release about 8 days ago, 9 days ago, that we've got reached out from a lot of companies. We actually have a company from South America flying here to Ohio on Wednesday to meet with us because they read about the press release and they called us up. We did a quick meeting. So it's a global phenomenon. We're a small 20-person startup. We've met everybody that we know. There's a lot of people we don't know. And so it's through venues like this that people find out about us. And I would encourage, if you have a data storage challenge or an opportunity, you'd like to discuss it. If you're running data center operators and you're concerned about these things, or you're concerned about the data explosion, please reach out. We're gathering information. We're always looking for new partners globally. Witness the meeting we're having on Wednesday, which is just, we're so excited about it because they told us their problem. And it's a problem you see elsewhere, but they're being very active in trying to resolve it instead of waiting for it to be solved in the United States and then a sales rep to come down to South America. It's that whole process. They're being very proactive. They have a data problem right now, and they're embracing technologies like ours as potential solutions. So we're real excited about that. So please come to our website, www.foliophotonics.com. Send us a message and we'll get back to you as soon as we can. We'd love to have the dialogue.
That's brilliant. It's been really, really entertaining to talk to you, Steve, and you've shared some great insights. So thank you very much indeed for your time. Thank you.
Thank you. And I really appreciate the time.